Good morning, grade 11. Hope you are all doing fine. This is Miss Pamela Teeny giving the physics course. Today we are going to continue Chapter 5, Section 2, Friction. If you all can open your books on page 130 so you can follow up with me. Now we will continue the section, Calculating Static Friction Force. The maximum static friction force relates to the normal force in a similar way as the kinetic friction force. So as we already stated that the kinetic friction force is directly proportional to the normal force, and the slope of their graph is equal to the coefficient of kinetic friction. The maximum static friction is similar in that way to the kinetic friction, so it is directly proportional to the normal force. Remember that the static friction force acts in response to a force trying to cause a stationary object to start moving. So whenever you try to get a stationary object to start moving, we have a static friction between the object and the surface on which it lies. If there is no such force acting on an object, the static friction force is zero. So if you are not trying to move the object, the static friction force between the object and the surface will be zero. If there is a force trying to cause motion, the static friction force will increase up to a maximum value before it is overcome and the motion starts. So before you start to push an object that is at rest, there is no static friction. Once you start, the static friction increases as your force increases, and then it reaches a maximum value. Once you overcome this value, the motion starts and the object moves. So in order to calculate the maximum static friction that has to be overcome before motion can begin, you use the following equation. The maximum force of static friction is equal to the coefficient of static friction times the normal force. Forces are measured in newtons, while the coefficient of static friction has no unit. The equations for the kinetic and maximum static friction forces involve only the magnitudes of the forces. They do not involve direction. Why? Because the friction forces are always perpendicular to the normal, so they only have an x component. And you can see in the figure in front of you, the normal force acts upwards, opposite to the gravitational force. And the friction force acts to the left, and it is perpendicular to the normal force because it is opposite in direction to the applied force. By rearrangement, we can calculate the coefficient of static friction by using the following equation. Coefficient is equal to the force of static friction, the maximum force of static friction, over the normal force. Note, please see Table 2, page 132, which shows coefficients of friction between various surfaces. Measurements of coefficients of friction are quite sensitive to the conditions of the surfaces. So the coefficients of static and kinetic friction differ according to the surfaces. Also, by rearrangement, we can calculate the normal force by dividing the force of maximum static friction over the coefficient of static friction. Note, recall that the normal force acting on an object is equal in magnitude and opposite in direction to the gravitational force of the object. So if you have in the given the mass, you calculate the normal force and then you continue by using the following equation. So normal force is equal to negative m times g, where m is mass measured in kilograms and g is measured in, where g is negative 9.8 Newton per kilogram or meter per second squared. Example, Jane is dragging a box full of toys from her room to the sitting room. The box and the books together have a combined mass of 12 kilograms. If the coefficient of static friction between the floor and the box is 0.42, how hard must Jane push horizontally on the box in order to start it moving? The solution is that first you find the normal force. Normal force is equal to negative m times g. So negative 12 times negative 9.8, and the answer is positive because the normal force acts upward, 117.6 newtons. Second, you find the force of Jane. So in the figure in front of you, you can see force of Jane is acting forwards. The force of static friction is acting backwards. Normal force is upwards and the gravitational force is downwards. Normal force and gravitational force are equal and opposite, so they cancel each other. However, static friction and the force of Jane are equal and also opposite. So in order to calculate the force that Jane must exert in order to move the object, we do the coefficient of static friction times the normal force. And we get the answer in newtons, of course. Please, as a homework, solve numbers 19 and 21, page 133, and number 30, page 135. Thank you and good luck.